Okay, so I hope you all can see my slides right now. I'm not going to full screen it. I know it's in a browser. I'm not going to full screen it right now because there are some things that I want to highlight and show you. So I kept them in open tabs right now. But I just want to welcome you all. Welcome you to an introduction to public health data science using the R programming language. This is a topic that I'm really passionate about. So I welcome you and thank you for spending your Saturday afternoon with me to do a little bit of learning and engagement. And I know this will be mutually beneficial for the both of us. So let me just tell you a little bit about what to expect. This workshop is going to highlight some of the main 4 steps. I have like 5 main steps of data science, but if you read different material, you'll see it broken down to maybe 7 or 8 or more, depending on who writes it. But essentially, it's going to cover you all the way from data acquisition to the prediction, to the modeling part of the data science pipeline, because we only have an hour and a half here, so I'm going to cover the most to get you where you need to be, and then the end, once you get more familiar, then you can start to do more predictive analytics. So who am I? I am a research analyst at the University of Miami Miller School of Medicine. I work primarily in the Department of Public Health Sciences, where my research focuses on those that suffer from substance use disorder. So I do work, everything that I'm about to show you is things that I do on a daily basis. Some of you might come across it and be like, oh, come on, this is nothing, or maybe you might get something out of it, but hands down, this is what I do on a regular basis, because we are going to be using data that comes from the census. It's an annual survey. It's called the American Community Survey. And when you do population science, you can't do population science unless you understand a little bit about your population. And so the best source of that for a lot of public health practitioners and analysts is data collected from the US Census Bureau. So that's what we're primarily going to be working with. So that's what I do. And I use a lot of that data to understand populations that that have higher than normal levels of those suffering with opioid use disorder. I'm not sure if I can see you. I can't really see you all, but maybe I can see the chat and I can see the participants. So I want to understand a little bit about you all, and how many of you, just raise your hands, use the raise hand feature if you have some familiarity with R and RStudio, because I want to gauge who has this is their absolute, they have zero knowledge of what I'm even talking about right now. So I see 2 people. Okay. There's 16 people in this group. So I hope, and if you haven't, that's okay too. That's totally okay. I designed this for even complete novices. So I want to see who already has a little bit of familiarity with the R programming language. Okay, so for those of you that raised your hand, go ahead and put your hands down. Even if you, now I want to see how many of you had a chance to go into the material and get R and RStudio set up on your local computers. This is very important, so please raise your hand. Okay, I see one person has not. All right. There's still a few of you that have not responded. And the reason why I ask is because I've set up a cloud environment for this course for those of you that didn't get a chance to set it up, but space is limited on the cloud environment. So I can't guarantee that everybody can use the cloud space. And it's just nicer. Okay. So there's, let's see, 1, 2, 3 out of, okay, so there's about 18 of us, about 6 out of 18 have set up R&R Studio. So we're gonna make this work. This workspace that I have right now only has 10 seats. So if we can't get everybody into one workspace, I have a backup. So we can make sure everyone can follow along. All right, so let me just, actually, I like having that participants, okay, you guys can put your hands down and feel free, this is a very open space. I actually prefer for you guys to cut me off. I think this is webinar style, so you can't unmute yourselves, but I will, if you have, I'm gonna leave the little participant window up. So if you have a question, use the raise hand feature, I'll unmute you. And then that way we can have an organic flow. And you don't have to, write down or keep your question memorized in your head until at some breaking point. That's unnatural. All right, so
unmute ourselves, just so you know.
Oh yeah, awesome.
Yeah, we can just do that just for demonstration.
Okay, thank you. Whoever said that, I really appreciate it because I wasn't sure if this is regular Zoom or webinar style, so that's really helpful. So even better, then I don't have to pay attention to the participants. I'm sorry. All right, cool. So just feel free to jump in when you have a question. It's more organic and it leaves room for engagement, and I appreciate that a lot more. All right, so let's see. All right, so a lot of you mentioned in the chat, or a few of you mentioned in the chat, the API. So this is the GitHub repository that contains the material for this workshop. In it, you will find the instructions to set up R&R Studio for Mac and Windows, so these 2 links. I intentionally did not insert the cloud links there because I didn't want people going in ahead of time and taking up space, but I will in the chat put in the link to the cloud environment for those of you that need it. And then for the data that we're going to be using, it is from the US Census Bureau, and it's going to be using an API. And I'll explain what an API is later. Some of you said that you never got your API key. That's totally okay. It may be because maybe it's the weekend. Maybe services are not as quick on the weekend. Either way, I have like a test API key. I've read the terms and agreements for the census. I have a API key that I've requested with a different account that I will share with you, but this is not good practice. This is just for the purposes of this workshop. I will decommission this API key after the workshop so that it will no longer be active, so you can't use it anymore. So for those of you that really were not able to get an API key, I will share it with you all. But please, if you did use your own, this is a good form when you are working with APIs. Okay, so let's go back here. All right, so you already know where to get to the material, but just in case, here's a little QR code. Go ahead and I'll give you guys a second to snap a picture of it, get it loaded, get the link up on your computer, however you want to do it. But just in case, let me also drop this. Actually, let me just put the main one. I'm going to drop this in the chat. So this is the material. And then the slides are actually, if you go to that link, the slides are right here on the right-hand panel. They're hosted. The PDFs are also there, but the PDF is static, and I prefer interactive slides. So there are going to be a lot of resources and links in my slides that you can, if you go to the web link, are clickable. They're active. All right. So let's just go ahead and get this big question out of the way. What is data science? I know it's a buzzy hot word that many of you are also like, oh, we already know what data science is. Well, that's great. But just to make it perfectly clear, data science is the practice of using real world data to try and understand and solve real world problems. It's really not new, even though it's been a hot topic, a buzzword for the past 5 to 10-ish years. It's really not new, it just went by different forms. We had in the 70s, John Tukey wrote, the one of the Tukey test, went and wrote a book called Exploratory Data Analysis. And in that book, he has a quote that says something along the lines of that he thought he was a statistician, but then as he watched mathematics and statistics evolve over time, he began to develop doubt, and then realized that his main interest is not actually statistics, but actually data analysis, which he felt was intrinsically an empirical science. So this is where we start to see that the data analysis process is in itself a scientific process. And then around the same period, we start to have database management systems start to emerge and people start to use them. And then by the late 80s, we get data mining. It starts to become a norm. So people are collecting all this data and then they actually need to mine them to answer their questions. And then by the 90s, we start to get what's called big data. This is data that is, constantly flowing. This is data that takes up lots of space. And in that, around that same period, not only was the term big data coined, but we also have statistician be used interchangeably with a data scientist. So the statistician and the data scientist start to merge and become used interchangeably. But that kind of changed in the 2000s when analytics were adopted as part of to kind of incorporate the addiction of predictive modeling. So by 2008, by some accounts, was a journal that published that explained the role of the data scientist, and then that's how we have data science in its form today. So it's data analysis with predictive modeling. But data science is so much, it's such a broad field and people get into it from all backgrounds and domains. And there's such an abundance of resources that, there isn't one way to become a data scientist. People ask me all the time, so what should I read? What resources? Can I become a data scientist even though I have an arts background? Yes, and yes. There is an abundance of resources and there is not one way to become a data scientist. And that's the beauty of it. You're not limited just based on what you chose to study in your undergraduate career. It really just takes one part mathematics or statistics, one part programming and database knowledge like SQL, and then one part of domain knowledge expertise. Because how can you make meaningful inferences if you don't really understand the questions that you're trying to answer? And that's it. You get a data scientist. So it's a really a beautiful field to get into, and it will never go away because data is literally everywhere. So they'll always be in demand. They may evolve, and you'll get a different. They may have a different name, just like in the 70s, you had statisticians, and then you had in the 90s, you had analysts, but data will always be everywhere and will always be in demand. So you'll never have to worry about that. So let me tell you how the untrained do data science. So you may have seen this workflow or may probably have done it, and I'm 100% guilty of this. Collect some data, plug it in an Excel spreadsheet, use the point and click tools to do some summary stats, use the import menu to import an analysis package that comes from some other like plugin. Microsoft likes to include little plugins in their analysis, in their product. Do the analyses, fix any problems. If you see issues in the analysis that comes that you do, fix the problems in your data in Excel, use that import menu again, rerun the analysis, do way more analysis until you get the answer to the question that you think you wanted, copy and paste numbers into Word or in PowerPoint, and then ship it off. I am like 100% guilty of doing this very early on. This is antithetical to reproducible research, which is one of the biggest foundations of data science. It is, if there's any takeaway that you will ask any data scientist, the key of being a good data scientist, it is being able to do things reproducibly. I don't know if I just made that word up, but I don't care. Reproducibly. So that is by far, I teach my students to make sure that whatever they do, that it is reproducible. You have to make sure you leave proper comments in your code, that your code is organized, that there's some form of modularity, that there's some form of documentation that goes along with your data, as in how is the data collected, all forms of things, which we'll cover on a little bit later on in the slides. So why R? You guys are probably asking like, how about Python? Like every job description that I read requires Python. Well, there are some out there that use R, but let me tell you why R specifically. This is in the field of health research and public health. You will find that R is probably a stronger programming language, even though Python has its pros as a general purpose programming language. R was specifically designed for statistical computing. People develop statistical softwares and data analysis, and hence why we use it a lot in healthcare research. So there are packages out there for survival analysis, specifically for bioinformatics, so you can calculate age-adjusted incidence rates, do power analyses, structural equation modeling. There's just like any strong statistical analysis that is required within academic research. It's very quick. Someone will come up with an R package for it, and it's open source, and they will push it out there. And that's kind of also one of the biggest pros of the R programming language versus other software like SAS and SPSS and Stata that you may use in health research, is because it's open source, which means that you can produce a package, but other people can contribute to it. There are, pros and cons to open source, but usually I think the pros heavily outweigh the cons. It's not proprietary, and you get things faster. And then you have a large, I cannot stress enough how big and how friendly the R community is. It doesn't take anything. We call ourselves, it's very nerdy. It's very, very nerdy, I'll admit. I am a user. It's like user, but with a capital R. And there are conferences, and it's super nerdy, but you literally can just ask a question on Stack Overflow or use the hashtag #RStats on Twitter, and you'll have an answer to your problem, I promise you, within like 10 minutes or less. It's a beautiful, friendly, and very inviting community to be a part of.
Could I interject real quick?
Yes.
I think you have two of the same question in the chat right now. And we're just kind of asking what you think of MATLAB and kind of your comparison between R and MATLAB.
Okay. So, MATLAB. So I don't know how I would compare the two. to be honest. MATLAB is more proprietary. I have to fully admit, I haven't used MATLAB since I was an undergraduate, like 14 years ago. So I can't really say, but I know that MATLAB is proprietary. You have to pay for the software, correct? So that is probably the biggest, yeah, okay, so it's proprietary. So that's the biggest, I would say, advantage to using the R programming language. And you can find everything that you can do in MATLAB in R as well. So R is a functional programming language. I'm going to explain what that is as well a little bit later on, but it's free and there are packages that allow you to do what you want, but also at the same time, and I'm going to introduce you to an ecosystem called the Tidyverse that makes it very human readable. It's a very elegant form of functional programming. There's never been an issue where I've needed to go back and think, maybe MATLAB might be the way to go about this. Even SAS, I actually got hired on as a SAS programmer. And there's still to this day, not a single problem I've come across where I've felt like an M+ as well for structural equation modeling. There hasn't been a situation where I've been like, I have to revert back to these softwares because just R can't do it. So somebody has come up with a package somewhere that will answer your question, most likely. And if not, there's another opportunity for you to develop a package in the future. So, and that's always an amazing thing, a really great line item on your CV. All right, so that was my little, I guess my little plug for R. Also because it's full of R nerds, and I run the local chapter in Miami of R Ladies, and I just love the R community very, very much. But let me just tell you that there are two different philosophies in R. You have base R, and that's what comes shipped out of the box when you download R in RStudio. And then you have something called the Tidyverse. So base R, and these are just some very common functions in base R. We're not going to touch upon it too much. You have the C function. So whenever you see something followed by a set of parentheses, that is a function. So C is the concatenate function, and that is probably the most commonly used function in the R programming language. Then you have DF. DF is shorthand for data frame. So you can have like my data frame. Data frame is a data set. It's an object in brackets. The brackets is how you subset a data frame. You have what is this? This is the less than with the dash. That is called the assignment. It looks like an arrow. That's the assignment operator. This is how you assign something on your right-hand side to an object, a named object. Order is for sorting your vector, so your column, by whatever variable that you place as an argument to that function. And then you have which is basically returns any indices that are true based on a condition. And it's hard to see now, just bear with me for a moment, but I'm going to show you all of these same base R functions in the Tidyverse and how easy it is to implement using the Tidyverse. Okay, so we have Lasali's is answering the question about MATLAB for specific math applications as calculus, graphs, higher mathematics. Okay, cool. Oh, okay, so the first two we have C is concatenate. So basically you can string together multiple things. So I'm just going to say things because you can either in the concatenate function, you can have a string. So you can have, let's say, table in character, in quotes as a character string, comma, 1, comma, 3, comma, another string. And then this is going to introduce something called coercion. So there are certain classes that trump other classes. So then you would have the 1 and 3 would become character, but concatenate just basically allows you to create a vector of objects. Does that make sense? And then the DF, the second object, the second bullet point is subsetting, is basically to highlight how data frames and base are subset. And it's using the bracket notation. DF is shorthand for data frame. And that's just, when you see DF, that's just pseudocode, meaning that pseudocode is just a more literate way of reading code without actually writing code. All right, cool. All right, so here's the difference between base R and the Tidyverse. The Tidyverse, and this is a quote from the R for Data Science book written by Hadley Wickham. He's a chief data scientist at RStudio. He says, at a high level, the Tidyverse is a language for solving data science challenges with R code. Its primary goal is to facilitate a conversation between a human and a computer about data. Less abstractly, the Tidyverse is a collection of R packages that share a high-level design philosophy and low-level grammar and data structures so that learning one package makes it easier to learn the next. So what that means is the Tidyverse, which I'm going to go over the design that does design philosophy in which he referred to, but they all share a similar design structure. So the Tidyverse is an ecosystem of R packages that all work very well together. They are designed in very similar way, and at a low level, like follow the same grammar, and grammar in this sense can be used just like spoken language, meaning the way that you apply the arguments and the data structure, so that if I know how to use one Tidyverse package, I can learn multiple very easily. They have very strong commonality, similarities between them, that it's very easy to pick up any package in the Tidyverse and use it because they are meant to work harmoniously. Oh, and one point I want to make, and you may hear this if you continue learning R in the future, that the Tidyverse is what's considered opinionated. So in the programming world, you have something called like an opinionated programming. And what this means is that the product believes its process is inherently better than the style from which it originally was developed. So meaning base. In this instance, the Tidyverse is considered opinionated programming versus base R. And I know several R programmers that strictly program in base R. They refuse to use the Tidyverse because they just don't find any strong reason to learn it. Mary is asking, and can packages in one ecosystem work with those in a different ecosystem? Can Tidyverse work with base R? Or do I have to stick with one? No, you can definitely combine. I will show you how in the code that we're going to be working with, but a lot of times you can manipulate your data using base R functions. The C concatenate function I use all the time. And a lot of times, well, lately in more recent iterations of the packages, you can pass in a vector as one argument to a function. So there will be a function, and then you can put as an argument C object, 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 object that way. So there, you can use them together and they will work for the most part. All right, so some of the main advantages of the Tidyverse, it's designed for functional programming. And what is functional programming? It's a way of thinking about programming as creating functions. It emphasizes the results and not necessarily not the process in which to compute the thing that you're trying to compute, if that makes sense. So R provides many tools for the creation and the manipulation of functions. So it lends itself to a style of problem solving centered on functions versus object-oriented programming. I'm not going to go into object-oriented programming at the moment. We'll get off on a tangent and we have limited time, but this is functional programming. So everything is a function for the most part. This is how you're going to use a lot of functions and create functions as you get more used to programming with R. You'll create your own functions to answer your questions, to figure out what needs to be computed. And that iteration. So if you find yourself, having to do the same steps, the same calculations multiple times, you create a function. So that is like the center of R. All right, so consistent functions, like I said, for the Tidyverse, we have a lot of the functions go together. Meaning that they provide a constant workflow. So you can continue to just use a lot of the Tidyverse together in one workflow, like a pipe. So there's a pipe operator, which I'll show you. So you can pass one object to one Tidyverse function, and the results of that function will get piped into another function. And then the results of that will continue to get piped into another function. So they all work very parsimoniously so you can get your end results. And it's very human readable. And so what I want to do right now is I want to show you, this was the part about functional programming. I wanted to highlight this example in a book I was reading on the advantage of functional programming. So here in this line of code, you have n assigned to the number of rows of a data set. Then this person is repeating an NA value for the number of n times. So for the number of rows, so each of those rows are going to get filled with a null value. And then they're using a for loop to say for every row in this data set, in n, right here, take the square root of the miles per gallon times 2. This is a lot when you can just write one function that takes in miles per gallon and weight of the car, and you just do weight times the square root of miles per gallon. And then you can pass in and use that function. This is the beauty of functional programming. All right, so let me fast forward a little bit back to where I was on the principles of the Tidyverse, some of the pros. So it's human-centered, as I was mentioning, designed specifically to support the activities of a human data analyst. So the functions are readable. It is consistent. So the way the functions are designed, there will always be, the first object will be a data object as the arguments. So, and that will be consistent throughout the development of all Tidyverse ecosystem packages. So what you learn about one function can be applied to another, and the number of special cases that you need to remember are going to be reduced, so as little as possible. It is composable. So this is what I meant, that you can literally pipe the output of one function into the input of another function, and the output of that function pipe into the input of another function, and you keep going, that parsimony. And then it is inclusive. So it's not just the collection of packages, but it's also the community of people that use them. So there are a lot of people, although their packages are not technically part of the Tidyverse ecosystem, they follow these unifying principles so that you can use other packages that are technically tidy. So I have also developed a package that uses REDCap data and tidies it up based on these 4 main principles. So it's that community aspect. So this is how data science with the Tidyverse would look like. I found this cool little graphic. We have, so you import your data, and there's here are the main packages you can use for importing data. You have readr, which is your main one that lets you read in your CSV, your R data sets. If someone already sends you an R data set, you have read Excel. This is especially for Excel, so .xlsx or XLS. Haven is good for other statistical software, so SPSS, SAS, Stata, for example. HTTR, RVES, and XML. This is for our scraping data from the web. And then tidying your data. So you have the Tibble and the tidyr packages. Transforming your data, you have dplyr, and dplyr is probably the most used out of all of these. The dplyr package has functions that are used. If you're going to use any functions, you're going to learn any functions, it's going to be the 5 main dplyr verbs that I'm going to go over, because they will just make your life so much easier. Forcats, HMS, lubridate, that's for dates, stringar for manipulating strings, visualizing with ggplot, modeling with Broom and ModelR. And this is actually a little bit dated. This is from 2007. We now have a whole other ecosystem just for machine learning. It's called Tidy Models, developed by Max Kuhn and Julia Silge. And then the programming part right here. We have Per and Magritter. So Magritter, I don't know if any of you all are familiar with the famous artist Magritte. He has a painting with a pipe, and it says "Ceci n'est pas un pipe," which means in French, this is not a pipe. So that package was named after him. So it's called Magritter, and it's a pipe. It's essentially the pipe operator, which I'll show you. And then Per is for iteration. So that looping through a function is what you will use. You will use the Per package for that. And these are all part of the Tidyverse ecosystem. And actually there are a lot more, I think there are a few more packages since this visualization was produced. I love this tweet. So Twitter is a very, very useful tool for learning about R and connecting with other users. And Andrew Heiss is a professor at Georgia State University. I follow him. He produces very useful content. And he tweeted very recently, actually, that he's been teaching the Tidyverse to his students for many years. And they tend to catch on to the pipe pretty quick because intuitively, it makes a lot of sense when you see it. So I want you to look. This is what the pipe looks like right here. This is the pipe operator. It comes from the Magritter package. In normal, in a lot of other, like without the pipe operator and other programming language, for example, you would do a lot of nesting. Nesting is when you insert functions into other functions because the output is needed for that parent function, and then that output is needed for the parent function from which it is in. And it's very, very difficult as a human to read. So he has this example. Without the pipe, he would leave the house, but in order to leave the house, he needs to get dressed. But before he gets dressed, he needs to get out of bed. But before he gets out of bed, he needs to wake up. And he passes all these arguments. So times 8 o'clock and make sure that he wakes up on the right side of the bed. But then in order to do that, to get dressed, pans equals true, and he needs to put on shirts. So shirts equals true. This is all just pseudocode. It's not a real function. But then to leave the house, he needs to make sure that the car equals true and the bike equals false. But with the pipe, it's very simple. You see, here's me. I wake up, at 8 o'clock, get out of bed on the correct side, get dressed with my pants and my shirt, leave the house with my car. It's very simple. So this is what the best parts of the Tidyverse is, the usage of the pipe operator. So like I said, the Tidyverse is specifically dplyr. It's my favorite package because it's most used for data transformation. It is designed for humans, and there are 5 main dplyr verbs. You have filter, you have arrange, select, mutate, and summarize. So filter, like I said, or like I will show you, filters your data frame based on a variable or a condition. Arrange sorts. So this is like those base R functions that I showed you. So these are their kind of their equivalents. Select selects, like subsets your data based on just the variables that you need. Mutate creates a new variable. And summarize allows you to do summary statistics on your data. And I know I have the little code time and the dancing dude on the bottom, but there's just one more thing that I want to mention before we hop in to the code, is that Unix philosophy. So the Unix philosophy, it is what the Tidyverse was kind of based off of. So Unix was developed by this guy named Ken Thompson, and he had this whole philosophy about how computer scientists needs to develop operating systems. And then in the 80s, you have a couple dudes, a couple men come after him and say, well, I'm going to expand a little bit about your philosophy. And then he came back and he had this like Zen approach to software development. And he basically broke it down into several rules. He had this one main philosophy, and then after several iterations, he broke it down. And I want to highlight rule number 4. And in the resources section of the slides, you can actually find and I have it up here on the tab, actually. There's like a lot to take in, but I want to touch in on number 4, and that is fancy algorithms are buggier than simpler ones, and they're much harder to implement. Use simple algorithms as well as simple data structures, which basically means write simple parts. Being clear is better than being clever. Design programs to connect to other programs. So this philosophy of modularity. So write one function that does one thing and does it really well. That way you don't have to find yourself repeating things over and over. Keep it in a script, use it in conjunction with other functions that do one thing and do it really well. And you can constantly use them whenever you need them without having to repeat yourself. And then when you must fail, fail noisily. Make sure you include something in your code that you will know your code is broken when it breaks, because it sucks. I will tell you, it sucks when you don't even know that you have a bug in your code because it seems to work perfectly. So Hadley Wickham, when he was designing most of the packages in the Tidyverse, had this philosophy in mind. And there are some specific, there's now a specific book dedicated, style guide to the Tidyverse. It is let me see if I have it up here. I think I forgot to put it up here, but it's okay. So it's called the Tidyverse Style Guide, and I added it to the end of the slides. But essentially, file names should be meaningful and always end in .r if there are scripts, unless there are markdown documents, so they'll end in .rmd. But avoid using special characters in file names. I cannot stress enough how much I hate when people will have spaces in their file names, have regular, like random characters, exclamation points. Just keep it simple. If files should run in a particular order, make sure to prefix them with a number. So that way you can see in your directory, the first file, the second file, the third file, it's gonna start with a number. Use commented lines of so in R, a comment is a pound sign and dashes or equal signs. This is how you can break up meaningful chunks of code so that your code, your script has flow. So we have the RStudio GUI. When it sees a pound sign, some text followed by a sequence of dashes, it knows that's a code chunk and you can easily navigate between code chunks. So it prevents a lot of unnecessary scrolling. Variable and function names should use only lowercase letters and numbers and dashes when you need them. So this is called snake case. And then generally variable names are nouns, function names are verbs. And you'll see this throughout the Tidyverse. So I just want to highlight that example. So you'll see in line 1 of my code, this is a code chunk. So I named this code chunk my vars. So it's a pound sign, the name of the chunk with a sequence of dashes. This is an appropriate variable name. So it's my _var. This is also appropriate. You can have numbers in your variable names. Just make sure that it cannot start with a number, but it can contain a number. And then I have a function and it is make names. So you have that verb make in my function name, followed by the parenthesis. All right, let's switch over. So I need to know, we're going to switch over into RStudio, into our code. So for those of you that have RStudio open, go ahead and actually open the r.rmd file. It's called import tidy transform viz.rmd. So for those of you that do not have R and RStudio set up, I have a workspace in rstudio.cloud, and I will put it in the chat. And if it fills up, sorry. Where is it? Here it is. Copy sharing link. And I'll put it in the chat, but there are only 10 seats. So not all of you may be able to get in, but for those of you that can't get in, not to worry, because I made a backup room. So I'll give you all a second to get in if you need it. Okay, we're doing good on time. So we still have 30 minutes to go through the actual code.
Could you also go through importing it into RStudios if you have it downloaded on the desktop?
Yes. So in RStudio, so here's my RStudio window. You just go to File and Open File, and then navigate to where you have the .rmd file located, and then just open. And while you guys are doing that, so our Markdown our Markdown in itself is a R flavor version of Markdown, which is a markup language. But I really enjoy when I teach or when I give seminars to have code in our Markdown documents, because it allows me to include my thoughts as text, and text that's marked up, so bold, italicized, all of these things underlined, and include my R chunks as well. So you'll see there's bits of code scattered throughout my notes. And the advantage of this is that when I do analyses, like if this was used for analyses, I can easily make this a report. There is a package called knitter, and you can just knit this document into either a HTML or a Word doc, and you can send it off to whomever you need it to send it to. So that's a really big advantage, because otherwise, if you had all your entire analysis in a .r, you would have to still find a way to make it presentable and communicable to your stakeholder. If you're programming just for yourself, by all means, I mostly use .r. Like I mostly create, like, this is a .r script. Oops. Right. And then, you know, I can just say, this is my code, and then continue, and you save it, and it automatically saves as a .r. So let's see how we're doing over here. Okay, so we have a couple people. Is it okay? How many of you are still, let me use the chat, the raise hand feature. How many of you are still getting into RStudio Cloud, the cloud workspace? Okay, I'll give you guys another second. And for those of you that are using the cloud workspace, I want to highlight some cool things. RStudio Cloud is really good for teaching for people that have never used RStudio before, because it already sets up in our environment. Granted, I went ahead in those workspaces that you're in, installed the necessary packages, because it does take a little bit of time, because it comes just like when you set up RStudio, like R and RStudio on your personal computers. It's just base R out of the box. So I went ahead and installed the libraries, and the cloud is a little bit slower. This is why I really encouraged you all to get it set up on your computers, because where there's limited resources on the cloud, so it runs a little bit slower. So I went ahead and installed the necessary packages for you. But you'll see RStudio has included a lot of learning tools that will help you. So there's a guide on how to navigate the RStudio Cloud, the features that are new. But one of my very, very favorite things, which I include, like, I'm not in my office right now, but in my desk drawer, I kid you not, there is the cheat sheets, and everything, like why would you remember anything if you have a cheat sheet? Honestly, don't like take up your brain space with things that you have a cheat sheet for. So I constantly use the ggplot cheat sheet. That is one of my favorite cheat sheets that I use, because it explains, you know, if you need to make this kind of plot, this is the geom that you're going to use. If you need to make this kind of plot, this is what you're going to do. Oops. I'm not going to go through that right now. And I'll let you guys continue with that setup of the RStudio Cloud, because I think you have to make an account. But I'm going to go ahead while you guys are doing that to talk a little bit about your typical data science pipeline. And this came straight out of R for Data Science by Hadley Wickham. He's actually working on the latest second edition, which you can find for free online, which I've included in the resources. But your typical data science pipeline is you import your data, you tidy your data, you transform, visualize, and model. And this is a cyclical process, because a lot of times you're going to find that as you transform your data and you visualize it, you may start to develop new questions that you didn't think you were there before. And a lot of times the transform and visualization, the exploratory data analysis process, is part of feature selection. So you're going to do a model and you're going to realize, you know, maybe your results aren't as good as you'd like. So you're going to go back and you're going to retransform, maybe create a new variable, combine some variables together to get better results. So this is why in that gray box you have an iterative process, because you'll always find that new questions are either being asked, or you're going to have to retransform something, or visualizations will show you some outliers in your data that will help your modeling process. And then at the end, you communicate. So the ggplot2, hands down, one of the best packages in the Tidyverse. It's based on something called the grammar of graphics, and Hadley Wickham developed this. I want to say like back in 2006 or 2007, he wrote a paper. That's when it first kind of popped up on the scene. And the grammar of graphics is it's like, you can consider it similar to the grammar of spoken language, in that this grammar is used to describe and create a wide range of graphics. Just like in spoken language, grammar is the whole system and structure of the language, like the consistency of the syntax and the morphology. ggplot uses the same approach. The syntax is also very consistent, except also ggplot uses what's called a layer grammar of graphics. And that means you can layer multiple features on top of each other. Like you have a scatter plot, and then on top of that, you can layer it. And that's what the plus operator, as I've mentioned here, a regression line on top. So it's a layer grammar, and it's beautiful. It works very well. And a lot of even data visualization experts use the ggplot and then export those plots into something like what's it called? Adobe Illustrator, to enhance their visualizations. All right, so has everyone got their RStudio, either RStudio Cloud or the code up and going? I see, oops, I don't need that. Just want to see, okay, we have a couple people in the cloud workspace. All right, so I'm just going to assume you all got into the workspace, and that, or you have it on your computer and you're ready to roll. All right, so the first thing that we do, so this is, I'm not going to get too much into the weeds of the structure of an R Markdown document. That's something that you can pick up in the R Markdown cheat sheet. But the first thing we want to do is we're going to install, for those of you that just installed RStudio on your computer, you can install the Tidyverse if you haven't already. It's a little bit of an install. It takes a little bit of time, but I have stuff to say in the meantime. But for those of you that are working in the cloud environment, don't worry about this step. It should already be installed. And if you want to just check, you can just do library Tidyverse, and then in the console, and then that will, if it complains, then maybe it's not installed, or it didn't install properly. Okay, so we have somebody in the chat. All right. So, all right, so we've loaded. So for those of you that have already have the Tidyverse installed on your computer, go ahead and load it. Though we don't need the entire Tidyverse. So I often try. All right, let's see, somebody has conflicts. If you're seeing, yeah, that's fine. So the conflicts, the Tidyverse is, that is totally normal. The Tidyverse lets you know that there are functions within the Tidyverse packages that share the same name as functions that come within base R. So it's just warning you so that, you know, if you want to use dplyer's filter versus stats filter, you need to call it explicitly dplyer : filter. So that's completely normal. That's actually, that was put there on purpose. So this is why I like to load, and the way that scripts there's a hierarchy is how the libraries are called. So if you call the dplyr package, it's going to pull from functions out of the dplyr package first, the first library that you called. All right, so we've loaded the first function that I wanted to show you in the 5 main dplyr verbs was filter. So filter does exactly what it sounds like. It filters your data down only to the observations that you want to keep, not exclude. This is an important fact you want to remember. So command enter so in our markdown, there is a play button that will run the entire chunk. Or if you want to see how each line runs line by line, if you're on a Mac, you do command return, that runs that one line. Windows, it's control enter. We'll do the same thing. And then we're going to take the miles per gallon data that comes out of dplyr. And you can, if you click on your global environment, my RStudio IDE is set up a little bit differently than what yours may look like. But I think out of the box, it's on the right-hand side, your global environment. And this is where the global environment is where all of your objects can be accessible globally. So if you can click on the MPG and you can see the data that's in it. So there are 11 variables and 234 rows or observations. So I just want to say, let me see which cars in this data set get over 30 miles, greater than or equal to 30 miles per gallon on the highway. So all I have to do is do filter, and I put the syntax here for filter in a comment. The first argument is always your data object, which is your miles per gallon. So this is the data set's called MPG, and then your variable condition. So within miles per gallon, there is a variable called HWY, which is highway, greater than or equal to 30. I can do this because if you hit that little down button, you'll see that HWY is an int. Okay, versus character versus model and manufacturer, they're character strings. So I can just put in the number 30. And if you do that, if you run filter, you'll get the output of that function, which literally is just, it's not storing it anywhere. It's just going to print it for you, either since it's R markdown, it's going to filter, it's going to present it to you in your script. Or if this was just in an R script, it'll actually show up in your console right here. It'll show up the output, so we haven't saved this to any object. So I may want to use this data in the future. So I need to assign it to something. So that assignment operator allows us to store the output of that function into a new object. So I have something, I want to create a new data frame called goodmpg. And I'm going to take that same filter command and assign it. And you don't have to write out explicitly less than sign dash. The command to do that on a Mac is option dash. So the option button in dash. And then in Windows, there's a button next to control. It's alt. That's what it is. I forgot. It's alt dash will give you the assignment operator. So if I just hit command return, I now have a new data frame with only 156 observations and 11 variables. for just the cars that have 30 or more. Actually, this is supposed to be 30, not 20. All right, so I'm going to give you about 1 minute for you to try, explore the miles per gallon data set, look at it, filter on a variable or two if you want to get a little fancy. But essentially, this is pseudocode. So name your data, use the filter function, add your conditions here. So you can use, if you're familiar with other statistical softwares, you can use less than or equal or equal. So, just to remind you, this is like a mathematical equal sign, like equal. The logical equal is two equal signs. This means that this has to equal your condition, all right? So let me just remind you of that one. All right, so now you guys have your own miles per gallon data set that you've altered. We're going to stick with that for the remainder of this demonstration of the 5 main dplyr verbs. The second one I want to show you is the select function. Select allows you to keep all your observations, but subsets your data only to the variables that you want to keep. Unlike filter, where it subsets your rows, your observations based on a condition, select will subset your data to only the variables that you want to keep. So in this demonstration, I want us to use the pipe operator. We've loaded the Tidyverse package, so it includes mgritter, which is the pipe operator as well. So in this example, I want to be able to keep the cars that only have greater than or equal to 30 miles per gallon. And I think, and for my particular question or analysis, I don't need all 11 variables. So I'm going to just select highway, DSPL, which I don't remember what it is, but let me show you a hint that's really helpful. If you do question mark in your console to any function or data object, you should get documentation for it directly in your help section. So the help section is where your files and packages are. So you just do question mark MPG. And there you go. So it is the fuel economy data from 99 to 2008. And you'll see that the data, the variables are listed. And so DSPL is the engine displacement in liters. So we have, I want to keep highway displacement, year, cylinder, city mileage, and car class. Okay, so let me see. I have some questions in the chat. So once you've created an RStudio Cloud account, there is, you should be able to just click on the link and it should take you directly to the workspace. The workspace should have this file. And if you click on this, this file, it'll open the project. So this is for those of you that are using RStudio Cloud, there is a project there for you. So it'll open the project space. And projects is an awesome feature in our studio. All right, so, and this should allow you to, okay, it looks like someone's having issues. Okay, so I'm going to ask you all to please put your questions in the main chat instead of direct message. And that will give you guys each other a chance to collaborate during, to collaborate and help each other as well. So let's see what's going on. Sorry, everybody. So let me see. When you enter RStudio Cloud and with the sharing link, you should be able to see in it one project. And if you go to projects, you should see the Tidy Transform Viz project and click on that. Okay, some of you are saying that they cannot find the projects on RStudio Cloud. This is interesting. Was anyone able to actually, can anyone permission change to everyone? So everyone, contributors can see the members list. That shouldn't make a difference. Can make their projects visible. I don't want, I can change project resources. That shouldn't make a difference. Viewers can see the member list. Let me make sure that I didn't accidentally do something. This is very odd. Was anyone actually successful? End up clicking on the new project and pasted the GitHub link. Was anyone successful in finding the project that I had already set up? Well, that's awkward. I wonder if the second workspace I created is going to have the same problem. I wonder why there's this lock button. do with it. This is interesting. I'm sorry, guys. I'm not sure how to unlock. I wonder if I change your roles to see if you can see it.
That worked. I have it now.
Okay. Oh my God, I don't know what's happening. I've taught with Cloud before, and I did not have this problem. I'm sorry, you guys. I hope that you guys were able to get in. Okay. Cool, guys. All right. So, oh goodness, we only have a little bit of time left. All right. So then we have the mutate function. The mutate is one of the most commonly used functions because it lets you create a new variable. So let's just go ahead and create a new variable that is it's going to be called combined MPG. And it's just, I Googled how people are able to create a metric called combined mileage. And basically you just take 55% city plus 45% highway, and then you get a combined mileage. So I did that. So I'm basically adding on to each step with the pipe operator. So we did filter in the first step. The results of filter is piped into the select. So notice that we don't have to include MPG in select. And then because that output is automatically passed as the first argument of select. So all the Tidyverse, especially in the dplyr, their first arguments are always a data object. So that is like implicitly passed in. So we have filter, then select. So then it goes through and then selects only the 6 variables that I wanted. And then creates a new variable called combined MPG. So remember a meaningful name, and that is using a round function so that I don't have, 10 numbers after my results. So it's just going to round to the nearest whole number. And so if I run this, you get good miles per gallon with my new column called combined MPG with the calculation between city and highway mileage. All right. And I'm going to need to hide my Zoom control so I can see what I'm doing better. All right. And then we have the arrange function. Arrange just essentially sorts based on a variable. So I have all of those, I've filtered, I've selected, I've created a new variable, and then now I just want to see which have the highest combined miles per gallon. And I do that by piping that result of mutate into arrange and using the descending function. And I think that is a actual read description file. Yeah, so is descending, it's a dplyr. Okay, it is a dplyr function. So somebody had asked if you can use them if you can use base R functions and in Tidyverse functions, you can. I thought descending was a base function, but it's actually part of dplyr. So that wasn't a good use case right there, but regardless, I want to see it in descending because arrange defaults to ascending order. So if I rerun good miles per gallon and take a look at it, now I'm going to see that the highest is subcompact cars and from 1999 with 4 cylinders, etc. Then finally, we have the summarize function. And the summarize function is a little bit tricky because it will only return the it will only return the summary statistic that you ask for, not your entire data frame. It's not mutate. You can do summary statistics in a mutate, but the summarize function will only return what you wanted summarized, if that makes sense. So you'll see it right now. So I want to know what the average miles per gallon is, average combined miles per gallon. So I've taken my original data, and really I didn't need to do that. I really could have just passed in average MPG pipe, assign that to good MPG. So that's essentially these lines 97 through 100 creates good MPG. And then type that, and I'm sorry guys, I forgot to tell you the command for the pipe operator. Instead of doing % greater than % manually, on a Mac, it's Command Shift M. And then on Windows, it's Control Shift M. Those kind of shortcuts make your life a lot easier. So for the pipe, Command Shift M. For the assignment operator, it's Option or Alt dash. And then to run a line, it's Command or Control Enter. And then I'll do summarize, average, combine. I'm just going to copy this because we like to save keystrokes and run that line. Now, remember what I told you about summarize? You only get a data frame with 1 by 1, like one observation, one variable. All right, so I had a question there. There's little questions that I've plotted, I've included. But one thing I want to make sure is to include ggplot in here. So ggplot is designed to work with data frames as a data source, not individual vectors. It has an internal syntax that's a little bit different than the Tidyverse because it has that layered grammar of graphics. And there's a whole paper on grammar of graphics that you can read. I've included it in the slides. And then you can also add as many layers as you'd like. So it typically takes on this form: ggplot, your data object, a geom function, and a mapping. So geom is the actual thing, is the geometry. I like to think of it as the geometry. So use geom bar for a bar plot, geom call, geom point for a scatter plot. And then the mapping, this is part of the grammar, right? So you have to have something to map onto, otherwise you're going to have a blank plot. So this is where you would have your X and your Y variables from your data object. So let's try it. We're going to load the ggplot library, and we're going to take our good miles per gallon data frame, and we're going to pass that into ggplot. And we're going to take only the X, supply only the X axis, which is our class, the class of vehicle, and apply to geom bar. And it'll spit it out down below. And it does a count. So when you use geom bar, you only need to supply one of X or Y, because it gives you a distribution. So almost like a histogram in a sense. So it gives you by default the count. You can use different metrics as your y-axis, but read the documentation and you can figure that out. All right, and then now let's look at a difference between cylinder and miles per gallon. And this is where we'll do y, X and Y for geom call. And you'll see that we have the combined miles per gallon versus class. So this is where I'm talking the difference between a bar and a column, a geom call. So because you get to essentially use the combined miles per gallon, but you have to be very careful with this one. And I made a little note to be very careful to understand the difference between geom bar and geom call. This actually, we don't have any cars that get 300 miles per gallon combined. This is a summation. So I want you to be very careful about the usage of these. And I put that in there on purpose so that you remember as you go through this one day in the future, if you need a reference, to take note, because I put here a little hint on reading the documentation for these two specific functions. All right, so I want to let's make a pretty ggplot with scatter and compare the years the car was made with the combined miles per gallon. And we're going to use hot pink dots. So you see, this is the layered grammar graphics I was telling you about. We have our data object and we use the pipe, but when we start to use ggplot function, we pass in our mapping, so our data object, our x-axis and our y-axis, followed by the plus sign. We use geom point, which means it's going to be a geometry of point, meaning scatter plot, and we pass in color. And this is where your cheat sheet for ggplot will come in so much handy, like it will help you so much. And then we're going to add a theme. So there are so many themes included in ggplot, and saying I want minimal instead of this default white and gray with lines. And then I want to adjust the labels of the X and Y axis instead of using the variable names. And what do you observe here? We observe that our data set really only contains cars that were made in 2008 and cars that were made in 2009, which is odd. But it's usually useful to see a continuous variable broken down by a categorical variable so that we can see any kind of covariation involved. So we're going to take that same data, but instead of doing Y as the combined miles per gallon, we're going to make it a density. And then we're going to add a frequency plot underneath. So let's just see how that looks before going into all of it. You can see that there is the color. We're not passing in one specific color, we're actually passing in the variable. So instead of including the class as part of our mapping, we're including it as almost a grouping variable. But this doesn't look so informative. So R thankfully tells us that bins equals 30. You might want to pick a better bin width. So this is for our density plot. So typically it bins data together. So if you think about it logically, our combined miles per gallon is only like 1 or 2 or 3 differences of miles per gallon apart. So 30 doesn't make sense. So I'm going to include bin width equals 2 and see we get a different looking graph. All right, so it is 2:35, and unfortunately, we didn't get a chance to actually work with our ACS data. However, if you were able to get your Census API key, you can very easily run the rest of this code on your own, because essentially we use the same methods, but to actual data from the census that's looking at our food stamps, people that have food stamps. And I was going to put it right here, just so you can see. Oops, I'm sorry, guys. Here it is. So which tracts within Miami-Dade County with higher incomes have higher percentages of food stamp recipients? This was our hypothesis. We have our data, which is the ACS table S2201, which includes the 5-year estimates of people on SNAP, and then the geography was all the census tract in Miami-Dade County. But you have all of the API key, you have the data, I mean, you have the script. So you should be able to just run this line. This is the key right here. Please, you have to store your API key in RStudio for the Tidy Census package to find it. And there is a function that stores it for you. You just have to uncomment this line. So you just erase the pound sign and put in quotes your API key, and then this rest of this code should be good to go. And Farzana is giving me the time's up look, so I think that's that is a wrap.